Welcome all of you to this video. I hope you all have started studying for physics by now. Okay, so this is a chapter from, I'm going to take a few important questions from the chapter force moment part of it. Okay, moment is a top favorite of ICSE, so I'm taking this up. Okay, this uniform rod question is very common, so I'm taking this up, and I'm also taking up few questions in couples and other moment questions. Okay, so I am trying to take up as far as a variety that can be taken from this chapter. Okay, so let's quickly see. So here we are given a wheel in which this is the axle. Okay, they told O is the axle. Calculate the moment of force about the center O and about the point A. Okay, now diameter of the wheel has been given to be 2 meters. Okay, if the diameter is equal to 2 meters, that is also given. Now if it is so, then this much is 1 meter, here is the radius which is another meter. Okay, so now what we are going to do is first find the moment about the center O. So if I am finding the moment about the center O, I have to take this distance, right? So moment about O, okay, that is equal to 2 into force into distance, perpendicular distance, right? And this is always at 90 degrees, remember, because it is coming tangentially. This force at B, 2 Newton, is coming tangentially, so it makes a 90 degree. So 2 into 1, which is 2 Newton. Second one, which they are saying is about point A. Okay, now we have to take this full length, so moment about A, which is equal to 2 into 2 into 2. This distance 2, now we are going to take this full length with this 2, which is 4 newtons. Let's take up this question. Find the resultant moment about the point O. Okay, now resultant moment you have to be little careful. Here 10 Newton is acting upwards and 10 Newton is acting downwards. Now why I took up this is for a reason, because this is working in one direction, this is working in the other direction. Now let's think about it for 1 minute. It's a very important question. Resultant moment about pivot O. Now the thing is, if this is the center, they have told this is the center, this much AO is 2 and OB is also 2. Now according to principle of moments, anti-clockwise moment is equal to clockwise moment, only then the rod is balanced. Here in this question, they have not talked about any balancing of rod. They just want the resultant moment about the pivot O. Now what to do? Okay, they have not told that rod is balanced. Rod is not balanced means rod is not straight. So maybe the rod is bent like this or it is bent like this, who knows. Okay, let's see. Now the moment due to force at A, and that is equal to 10 Newton with this 2, that is 20 Newton. Let us talk about the direction. Let's talk about the direction. The direction is, if I take this, okay, and if this is being pushed, it is fixed here. You can think of it as a rod is fixed here, that's the pivot, and you are pushing it upwards by this force, okay, it is fixed here. Then it is bound to make a circular motion. Okay, so it is not going up, though they are giving the force like this, it is finally going to go like this, okay, so it becomes what? Clockwise. Now let's talk about the other one also. Moment due to force at B, and that is again 2 into 10, which is 20 Newton. Okay, that is 20 Newton. Now let me quickly talk about the direction, okay, clockwise or anti-clockwise. Now why I took up this question is, people, the moment they see this is clockwise, that they make anti-clockwise. That's the big mistake they do. Okay, so here this is, if supposing it is, you push this, okay, you're pushing this also, you're pushing that also, finally it's going to make a circular movement like this, isn't it? It's going to make a circular movement like this. So this is also moving clockwise, even that one, this part is also moving clockwise. So both the forces are making the rod move in the same direction. Okay, though here they look opposite. That's the reason I took up this sum. So here moment of force due to force at B is 20 newtons, again clockwise. Okay, this is again clockwise. Okay, if so, now what is the resultant? Means the total. Now since both of them are in the same direction, we are not going to subtract, we are going to add. Therefore, resultant moment is 40. Resultant moment is 40 what? 40 Newton clockwise. So you must keep writing the direction. Okay, that means in other words, this is moving this way, that is also making the rod move this way. Finally the rod moves like this. Okay, and with a moment of 40 newtons total. Here I want to tell, if this was like this, at B it was like this side 20, moving it clockwise, that was 20, making it anti-clockwise. Okay, so what would have happened? This side 20 and that side 20 would have finally clockwise and anti-clockwise movement would have been same, rod would be balanced in this case. So here in this sum, don't put according to principle of moments clockwise moment is equal to anti-clockwise moment, because nowhere in this question they have talked about balancing the meter rule, or that they didn't say the meter rule is balanced. They just gave this diagram. They told it is pivoted here and they told it is length is 4 meter and they told this is 10 Newton, 10 Newton. They just told find the resultant moment. Okay, they didn't say it is balanced. Unless they say it is balanced, you are not going to write according to principle of moments total clockwise moment is total anti-clockwise moment. This is what people write. Okay, don't write this. Here is a sum they have given as a diagram like this. Okay, and O is exactly at the center of these two lines. This difference is a 50 centimeter mark. It is a centimeter, not a meter. Okay, calculate the resultant moment about O. Moment about O and about B also you have to find. Okay, and then about O. Moment about A, moment about B and about O. How do you find it? Okay. Now remember here they have told in the question, okay, I am not writing the full question, they have told these are two forces which are equal in magnitude and opposite in direction. We can see that, okay, that they are equal in magnitude, 10 Newton, 10 Newton and opposite in direction. Okay, now if they are equal in magnitude and opposite in direction, then don't take it in the beginning only as a, what? As a that uniform meter rule sum. Okay, if you do that in a uniform meter rule, the pivot is at the center. But here for a couple what happens is the distance between the two forces. Okay, the distance becomes the distance between the two forces according to moment of a couple. So a moment about A is going to be this 10 Newton, of course. So moment about A is equal to 10 Newtons force into distance, which is a 50 centimeter, 50 divided by 100, because this is SI, this is 50 centimeter is not SI, be very careful. Okay, so here this is 5 Newton meter. Okay, moment, so we have to take this full distance because it's actually a couple. Yes, let's take moment about B. Moment about B, that is again 10 into 50, 50 by 100 to make it meter. Okay, 5 Newton meter. Okay, now they want moment about O. When they want moment about O, now this question changes to your uniform rod type of question. Okay, it changes to your uniform rod type of question, and then you will have to take this as a 25 centimeter and this one as a 25 centimeter, and then moment about these two things, they are already in opposite directions. So like in the previous sum, it's very similar to that. Moment, total moment about O. Okay, I'm going to find them all together. This is 10 into 25 by 100 plus again 10 into 25 by 100. Okay, and that makes it 2.5 plus 2.5, 5 Newton meter once again. Okay, it's okay, we got the same result everywhere, but then you'll have to follow this method. Okay, so remember when they do this, okay, one thing I missed in each one of them, when it is going this way, this is clockwise, this is also clockwise, just like in the previous sum. Okay, so everywhere I have to write clockwise. Direction is important. Everywhere I have to write clockwise. Okay, and here also it is clockwise. Total movement is here also it is clockwise. Okay, so this was actually a couple sum for the first two parts. For the third part, it became a uniform rod kind of question. This is a very important question. High chances of coming. Every question paper, pre-board question paper will have one of this. Uniform meter rule balances uniformly. Now look at this. This sum has to, you have to read a lot of things in this question. They told it is balancing, means it is straight. Okay, balances uniformly. Now before that also we have to note something. This is the word meter rule. Okay, meter rule means this is 100 centimeter, 1 meter rule. Okay, so 100 centimeter, 50 centimeter is here, 58 is here. Now they told knife edge is here, means it is pivoted over this place. Okay, and not at the 50. Generally it is pivoted at the 50. Now they are saying it is made balanced by a weight which is kept somewhere, we don't know where. Okay, but a weight is kept 20 gf at one end. Now here we have to use our common sense. Okay, what we have to understand? See, if this is a long, this is a scale, maybe this is a scale, and this is the center of the scale. If I keep it at the center, okay, if I keep this, if I am pivoting it at the center, well and good, both sides equal weight, it remains straight, then it's not a problem. But if I don't keep it at the center and I keep it slightly this way, naturally the side which is more in length, the pen will bend towards that end, the thing will bend towards that end, other end will go up. Now if I want to keep it straight, in spite of not keeping it at the center point, then I will have to hang something to the other end to bring it down, otherwise it goes down like this because more weight this side. So I'll have to put something here to make it straight. Now they have not told us clearly which end the 20 gf is kept, because they want us to understand, and that's why they told draw the diagram, because there's marks for the diagram in this. Okay, so if it is knife edge is here, okay, this is the heavier side. Okay, so if I keep something here, then it will go like this, it doesn't come straight. So what to do? We have to keep something here. 20 gf makes it straight. It is balanced by the 20 gf. Why is it balanced? Because total clockwise movement now became equal to total anti-clockwise movement because of this. Why? This side no weight is there. Then how come it is balanced? Okay, it is balanced because the weight of the scale is supposed to be working from the, is assumed to be working from the 50 centimeter mark. Okay, anything from the center point, the weight is acting. So the weight is acting this side, the weight is being balanced by this 20 gf at the end. They told at the end, but they didn't tell which end. Okay, so now I'll be writing the equation. Here I know this much is 8 and I know this is a 42, that also I know. Okay, but I don't know this. So the weight becomes an x, weight is x, I take this as an x into 8, sorry, x into 8, because this is the moment. Okay, it is the clockwise moment. Okay, this is the anti-clockwise moment, sorry. So I think I'll write it this side, 50, this is 8 into x. Okay, that is total anti-clockwise moment, this one. This is the clockwise moment, which is 20 into, this is 42 centimeter. Now note another thing in this question, this is 20 gf, not kgf. Okay, so here if in these questions the scale is a centimeter, it is graduated in centimeter, it is marked in centimeter. Okay, and then they give the weight in 20 gf or 20 gf, no problem. If you are writing 20 gf here, you are not converting it to 20 kgf, don't worry, your answer comes in gf. Okay, here if you are converting it to 20 kgf, okay, then your answer will also come in kgf. Why so? Because in this we don't have to change. Why? Because it is multiplied on both sides. Here 42, if I would have changed this 42 centimeter to, let's say, meter, I would have divided with 100 here and this 100 also here. Okay, so supposing if this would have been in kgf, here it matched, here the entire sum is in cgf, but supposing I would have changed it to, I want to, if this 20 was in kgf, then I had to do this in order to keep the entire thing in SI. But then note this, whether you multiply with 100 or you divide with 100, this finally cancels out. So if they give 20 GF, leave it as 20 GF, no need to change anything because you are multiplying both sides. So automatically your answer will come in GF. Okay, so anyway, here in this question there was no mismatch. I was telling you something when there could be a mismatch. Okay, so x is equal to 20 into 42 by 8, 8, 4 2s, 4 5s are 2, 21, 105, how much? 105 GF is the answer, that is the weight of the scale is 105 GF. Okay, so this kind of question is very important, where they don't give the weight of the scale and they expect you to find it. Where do you go wrong? You go wrong in, this measurement. Okay, 58 to end 100 is a 42. You go wrong in this measurement, you tend to take it 58 and all that. You go wrong in changing the units and you start confusing because it's given, maybe it's given in kgf, centimeters se kaise sum kare, so you keep on changing it and doing all that. There you go wrong. Okay, so just watch. Another thing you have to see, I hope they give 50 centimeter rule. If they don't give a meter rule, they give a 50 centimeter scale, the story is going to be different. Okay, so please watch the words. Okay, click carefully. And now, and always this 20 GF, the main thing where people go wrong, they will put this 20 GF in this end. Some gone wrong because your rod has now become like this. Rod is not balanced anymore. Okay, so understand this and do this. Here is a question, uniform meter rule. Okay, again we'll see this, very important. Pivoted at its midpoint, that also is important. Okay, 50 GF, okay, 50 GF and suspended at one end, where should a weight of 100 GF be placed to keep the rod? A weight of 50 GF, that means something has been suspended, so it is at the midpoint, at the 50 centimeter mark, so that way no problems like the previous sum. Now here a weight of 50 GF is suspended in one end, so 50 GF is suspended in one end. It's like a seesaw. Okay, if you are if a lighter weight person is sitting this side, okay, at one end, then the heavier weight person should sit closer to this, isn't it? Okay, so to keep it horizontal, so the heavier weight person will not be here, but rather he'll be somewhere, okay, somewhere before this. Okay, so now we don't know where it is, because to keep it horizontal, that is to balance it. So what do we do? Here this is 50 centimeter, so 50 into 50. Okay, so everything is in GF. Total clockwise movement this side, anti-clockwise is coming this side. Clockwise is, we'll take this distance as an x into 100. Okay, here the CG plays no role. So here I can write x is 50 into 50 divided by 100. Okay, so that makes it 25. Okay, 25 centimeter. 25 centimeter from where? Be very careful. 25 centimeter from here. That means 75 centimeter from the other end. Okay, from the other end. That should be your answer. Where should a weight be suspended? Okay. So these were few of the questions that can come from this chapter according to me. And also apart from this, I want to tell that we were doing this kind of sums. Here only we talked about 2 weights every time, max 2 weights. But then there can be 3-4 weights also. So in that case, all you have to do is calculate the total clockwise movement and equate it to the total anti-clockwise movement if the rod is kept in balanced position. Okay, sometimes they even use the word equilibrium, they use balanced, okay, they use horizontal, anything. So you have to carefully calculate the total clockwise has to be equal to the total anti-clockwise. Okay, now if one side moment is more and the other side moment you see is less, okay, so you have to get the difference. You have to get the difference. Supposing in one side it is 25, other side it is 50, then the difference is a 25. Okay, so now you have to see which is bigger. If this clockwise is bigger, okay, if you see clockwise is the bigger one, after writing the difference you say 25 Newton meter clockwise. You have to mention in this kind of a case the rod is not horizontal. Okay, that means one side there's a bigger pull, there's a bigger force, and which is making it turn. So it is in a slanting position. So 25 Newton meter clockwise. So if you have unequal one, rod not balanced, check for the bigger one. Take the direction of the bigger one as the resultant direction. Okay. So that is it for today. Please check the playlist for physics ICSE 10th. Okay, you'll find all your physics videos there, and also chemistry videos. Also, I'm uh, chemistry videos also I'm uploading simultaneously. Okay, so keep watch on the channel and let me know in the comments how you are liking my videos. Okay, then do not forget to subscribe for 11th standard videos later on. Thanks all of you. Bye then.